Hello everybody. I am very excited for this lesson because it's something I love to do, analyze projectile motion. It has a lot of applications in sports, in the military, as well as your day-to-day life. So it is my pleasure to bring to you this little, very exciting topic. It's going to take us about 5, 10, 15 minutes. But we will analyze some of the most profound concepts about motion, something that you can actually observe and test and it will work. So we will look at oblique projectile. We call this surface to surface projection because we launch a ball on the surface, it follows a parabolic path and lands back on the surface. To give you a quick demonstration, this is the ball. I launch it. It follows a projectile path and it lands back on the surface. So we will analyze this motion conceptually, graphically, and mathematically. So stay tuned and please, as I interact with you, to stay engaged, take some notes, follow the lectures, pause, rewind, as well as if you have any questions, put it on the discussion forum for this class. Now, this is a two-dimensional motion. Why do I say that? Because at every point, this is V naught, we can resolve this. This is Vx, and this is Vy. If we take it here, this is V, which can be resolved to Vx and Vy. So you see that the velocity of the ball or projectile at any point along the path can be divided or resolved into two components. You have the x component and you have the y component. Now, the maximum horizontal distance is what we call the range. The maximum horizontal distance is what we call the range. This is the maximum height. Which I will represent here as y max. So the very first thing in analyzing any two-dimensional motion is to analyze the horizontal motion separately from the vertical motion. Let me say that again. Always analyze the horizontal motion separately from the vertical motion. Now, to make this easy on you, let's choose our coordinate axis. This is the y-axis and this is the x-axis. That being said, we have the x, you have the y. This is our initial velocity v naught projected at a certain angle theta. Right here you have the y component, and right here you have the x component. This is VOY, this is VOX. We will use trigonometry in order to express the x and the y component in terms of V naught. We know from SOHCAHTOA that the sine of theta is equal to opposite, which is VOY, divided by the hypotenuse. This is V naught, which is just V naught. What this means is that VOY is equal to V naught sine of theta. keep this in mind. VOY is equal to V naught sine of theta. Similarly, cosine of theta is equal to VOX divided by V naught, which implies that VOX is equal to V naught cosine of theta. VOX is equal to V naught cosine of theta. So essentially, we can represent the initial velocity in terms of its components as V naught bar will be equal to VOXI plus VOYJ, which can be expressed as V naught cosine theta I plus V naught sine theta j. So this is the velocity expressed in terms of its components I and j. Now, just like business as usual, we will look at the horizontal motion separately, and as well as we will look at the vertical motion of this projectile separately. So let's start first with the X motion, or the horizontal motion. For the horizontal motion, x0 is 0, ax is 0, you know why, and vox is v naught cosine of theta. This right here represent the initial conditions. From the kinematics equations of motion, we know that Vx will be equal to Vox plus AXT. This will be equal to V naught cosine theta plus 0t. That would mean that Vx is equal to V naught cosine theta, which is just Vox. Obviously, we expected this to happen because the acceleration in the x direction is 0. If the acceleration in the x direction is 0 as the case, it means that the velocity does not change in the x direction. Remember that acceleration is defined as the change in the velocity of an object with respect to time. That means that if the acceleration is 0, it really doesn't necessarily imply that the velocity is also 0. It definitely means that the change in velocity is 0. In other words, the velocity in that direction remains constant. It is something that you need to ingrain in your minds. So, we will have here x equal to x naught plus VOXT plus 1/2 AXT squared. We know that the acceleration in the x direction is 0. We know that the object begins moving from the origin. This would mean that x will be equal to VOT cosine theta. This tells us that the horizontal distance increases linearly with time. This tells us that the horizontal velocity does not change with time. So if we want to represent this graphically, how will it look like? We will have here t, this is v, this is vox. Why? Because ax is equal to 0. This is t, this is x, and it's gonna be a straight line. Why? Because vx is equal to vox, which is just constant, and that is reflected by the slope of this graph. Thank you, and see you in the next lesson.